Okay, let's see. Am I live? Just check the audio. I said I was gonna take a break, but actually I don't really want to take a break. Well, I do want to take a break. Maybe I'll take a break after this one. Let's wait for the audio. Hello, hello, hello. Let's wait for the. Yeah, okay. Don't want to take a break just yet. I don't actually know what I'd do if I took a break. I don't really know what to do. So we'll keep going. Yeah, we'll just keep going. I think I want to go till 8:30 my time. It's another hour. Satisfiability of equality equations. We're given an array of strings equations that represent relationships between variables where each string equations of I is of length 4 and takes one of two different forms, x of I equals y sub I, or x of I is not equal to y sub I. Here x of I and y sub I are lowercase letters, not necessarily different, that represent one-letter variable names. Return true if it is possible to assign integers to variable names so as to satisfy all the given equations, or false otherwise. Equations a equals b is not equal to a, false. We assign say a equal to 1 and b equal to 1, then the first equation is satisfied, but not the second. There's no way to assign the variables to satisfy both equations. A equals b equals a. True, we can assign to both a to satisfy both equations. There's 500 of them, the length is 4. I of 0 is a lowercase letter, I of 1 is either equals or not equals, or not. I of 2 is equals, I of 3 is a lowercase letter. Okay, immediately not really sure what to say about this question. This is like, also I have too many of these things open here. Hold on a minute. Okay, I don't know the answer to this. This is like quite a question. I think pop the chat out. Yeah, I keep forgetting to I have to close the chat and then pop the chat out again. Yeah, this is not obvious what to do here. Array of strings of equations represent relationships between variables where each string is of length 4. Represent one-letter variable names, not necessarily different. Okay. Okay. Possible to assign integers to variable names so as to satisfy all the given equations or false otherwise. Okay. Well, basically, it's always possible as long as you don't have a contradiction. Only time you have a contradiction is when two variables are not equal to each other. Or excuse me, when they're equal to each other and not equal to each other. So you could say, well, there's different ways of doing this. You could just say for each variable have a just an unordered set of the other variables that it's supposed to be equal to, and an unordered set of the variables that it's not equal to. And when you try to add a variable, you just have to check that when you add an equation, right, for both variables, if one is supposed to be equal to another, but that other one is in the not equal set. Well, actually, you could just have pairs. How big are the numbers? Is a lowercase letter, right? So actually, you could be a little more clever about this. Ready for this? This is going to be kind of a weird way of doing it. So we're going to use a Boolean array of equal and not equal, and these are going to be of size constant bound is going to be 26 or 25, really 0 to 25. I think 26 is actually correct, and we're going to say it's going to be bound squared. Bound 2 square bound. Bound times bound, and the idea is Make this all false initially. Okay. Oh. I don't know if this is going to work the way I'd like it to. I think it does, but so I'm going to keep track of these pairs in this way, which pairs I have to deal with. So basically, I'm going to represent each equation pair with a key, and that key is just going to be, we'll call it, A and B, where A is the first value. It's a character, so just subtract A from it. So if the character is Z, that would be 25. If the character is like B, it's going to be 1, right? Subtract the character A to get those values. And then, so ZA would be a pair, right? And I just multiply Z by 26 and then add the other value, which was, we said, not Z, it's going to be 25 times 26 plus the 1. And it could be 25 times 26 plus 25. That's the highest value you can get. Yeah, that'll work. Okay, that's fine. So, excuse me. So we'll do the following for each equation. Right. A is going to be S of 0 minus A. B is going to be S of 3 minus A. And we're going to say we get all the way through this, return true, otherwise return false. See if we see any contradictions. We're going to get the key is going to be A times the bound plus B. And we're going to say constant or bool type is going to be the second character, I think. Yeah, 0, 1 is either equal to A or not, so it depends if it's equal to equal. Say that's S of 1, right? Okay. So depending on the type, we're going to say if the type is, or it's an equal type. So equal type, then we're going to say equal of key equals true. Else not equal key is true. And there's another check that's going to happen is say if not equal of key, then return false. And we hit our contradiction. And the other way around, if equal of key has been set to true already, also return false. Something like this. I think this works. Let's try this out. How am I doing on time? 8 minutes? Oh no! Output true should be false. Oh, okay. Key 1 and key 2. I forgot about that. You got to do both keys. Yeah. Okay, I did that wrong. Yeah. All right, let me see. There's something else here though that's kind of tricky. There's a subtlety, which I think this should almost correct. There's just A equals A is one thing that's kind of tricky. Oh, it's fine. Why would, what? Oh yeah, okay. What if I did that? Oh, huh. Yeah, there's one slight detail here. This always is true. It's always equal to itself. That's one slight thing. I don't know if there's anything else. There could be some other tricky things that I'm not really thinking about. I'm just gonna go for it. There's probably something wrong. I'm not gonna think about it. I'm just gonna go for it. Oh no! Oh no! I did it wrong. I had the wrong idea. I thought it was so simple. No, not that simple. Oh, I didn't even think about that. Oh no. Uh-oh. Ah. That's a mistake. Oh man. I did this wrong. No. Should have thought that through. I didn't even think about that. I'm going too fast. You could use like a disjoint set data structure to do this, to create like the union. But that's I should have thought about that a little bit more. Well, whatever. I don't know. I'm going quick. That's the idea. I'm trying to go very quick. Yeah, there's a problem with that, right? All of those. Gotta take a deep breath. Sorry. YouTube is like upsetting. I looked at some of the videos on YouTube and I was like, oh my god. It's like, this is, yeah, upsetting is putting it lightly. Anyway, the thing to consider here is the problem is that the keys, when they're set equal to each other, oh, that's very awkward. Yeah, I have to consider when a few things are set equal to each other and then something is not equal. Basically, it's transitive, the things that are equal. And I think I should make a graph. I think that's the way to go. I could use a disjoint set data structure for the things that are equal to each other. And then just check things that are not equal. If anything that's supposed to be equal is then not equal. Huh. I could use a disjoint set data structure. That's probably the easiest way to go. Now I'm thinking about it. Yeah, that's probably the best way to go. Yeah. Okay. That's probably the best way to go because it's kind of confusing otherwise. I think I should do it that way. That was okay. Not the best idea that I had. Thought maybe this would work, but it's not really the best. I think I have a better idea. All right, so let's build a disjoint set data structure. You just need a couple routines. One of them is merge and merge find, or merge find, and the other one's find. Find and merge find are the only routines you really need. And the things that you're going to want are, gotta use a vector actually. This is going to be the, just say the array is fine. And it's going to be size 26. Yeah, that's fine, 26. I think it's just iota. Fill this. Array begin, array end, 0, right? And we're going to run a find, A and B, index. We're going to do find merge, index 1, index 2. Find merge is it's A1 or just A. Do it this way. A is index 1, find index 1. B is find index 2. The way find works is you have int like current, or you have like parent and grandparent. This actually shouldn't be, should stay what it is. Yeah, this shouldn't be that way. You're going to want to have array of p. This is not going to be a vector of integers. This is going to be a vector of disjoint set data structures, DSDs. Struct DSD has it's 3 integers. It's going to have its index, or its index, its parent, and its size. And each of these okay, so we're going to push these DSDs. Technically, I could do this a little. I could probably do this better, but this is fine, I think, as it is. All right. Now the find, you get array of p is a DSD. We want the array of ix dot parent, and the grandparent is going to be array of p dot parent. And we're going to do a while loop. While ix is not equal to p, return p, and we're going to update update ix to p, update p to gp, and update gp to gp's parent. And we're going to do a double. It's a half compression, they call it. So it's going to be you're going to set the parent of ix equal to the grandparent. Yeah. So you take the bottom node, make its new parent the grandparent, and you just do that, and you go all the way up. To perform the find merge, you just double find A and B, and then you say if whichever one's smaller, you're going to swap A and B. Actually, if A is equal to B, then you just return. It's already merged. Otherwise, you're going to say if A dot size is less than B dot is greater than B dot size, and swaps. That way A is smaller. And think for a second here. I think that's all you need to do. Yeah. And then whichever one, the smaller one is going to be merged into the larger one. So A is going to be merged into B. So A dot parent is going to become B. B dot size is going to absorb A. And I think that's all you need to do, actually. Is that it? I always get kind of unsure when I'm writing a disjoint set data structure. I always like forget something important. Find A and B, take the one that has the smaller size, and merge it into B. It just means you make the parent of the smaller one the other with B, and update the size of B. That's really it. I don't think you really do much beyond that, quite frankly. Yeah, so we got find with a half compression, merge, and we've got a disjoint set data structure ready. Now we can say for each of the equations, I kind of messed up before, but that's okay. String equations, we can do const int, or just, yeah, well, int a is s of 0 minus a, and b is s of 3 minus a. And now we can say if, we can say const bool equal type is going to be s of 1, I think, equals, right? So if equal type, then we're going to say, so we do first one routine where we're looking for just that equal type. We do 2 passes. I think it's fine. The first pass, we're going to say if equal type, then find merge, really. Find merge of A and B. And then if not equal type, then we're going to check for contradiction this way. I don't know, there might be a better way to do this, but it's just my thinking is it's probably easier with a disjoint set data structure. It's just kind of very simple if you do it this way. If it's not equal type and find of A is equal to find of B, after we've created our kind of relationships between the variables, then we have a we have to return false, right? Then we have a problem. Then we have a contradiction, right? Oh, yeah, okay. Oh, yeah, okay. I was getting a little bit confused. That's, I think, what I tend to get confused about is usually like to use a pointer alpha. Yeah, I was gonna say, I'm pretty sure I do something kind of unusual here, usually. That's what it is. Got it. So it's gonna be, I don't know why. Yeah, so if the alpha size is greater than the beta size, then we're gonna swap alpha and beta, and then we should be alpha p, not beta. It should be b and alpha size. Yeah. Get a little more confusing, but hopefully that works. It makes sense. Is it merge find or find merge? Let's try that. Maybe that works. Hey, there we go. All right. I think that works in general. I could be wrong. I'm gonna try it. Just go for it. There could be something wrong that I don't realize. Oh, come on. What is wrong? Okay. A is F, A is B, A is C, A is Z, B is E, C is F. Okay, they're all merged. A, F, A, C, B, E, A, B, C, F. They're all merged. And then at the end, I look at F and E, and they should be the same. Why it should be false? What happened here? What happened here? I think I must have misprogrammed, implemented incorrectly. I don't think the logic there fails, or should not fail. Also, this is like, come on. Checking the. Pretty bad. You got 2 wrong answers. It's not great. Don't like that. So it should be 0, 1, 2, ABC, not 3. ABCD would be 3. E would be 4. 0, 1, 2, 4. And then F. Oh, there's no D. F is like 5. So 0, 1, 2, 4, 5 should all be like merged together. 0. Okay, this is wrong. Right. Something's not right. This is A. It should be merged with B. Okay. We'll just say character of I. Character of A plus I. Okay, let's do this at each iteration of the equations. Maybe I should convert this to a character too. All right, so after each iteration, and I should have another separator. I probably just made a mistake implementing the DSD. I do that like every time. It's like, doesn't matter how much you prepare for these questions, you're always gonna you're always gonna make a mistake somewhere. It's always a chance. It's kind of absurd. So A is equal to A. So after the first equation, A should be equal to B, right? Oh, excuse me. F is it was second equation. Okay, second equation. A should be equal to B. The first iteration is fine. The second iteration, they should be the same. This is kind of a problem. Somehow they're not equal to each other. Okay. Merge find. They're already equal. And stop. Otherwise, we say alpha is array of A, beta is array of B. Take the size of alpha is larger. We're going to swap the two because alpha is going to become merged with B. Iron is B. How and beta size is going to be incremented by alpha size. So what is A, B, B? What is going on here? Okay, 0, 1. What is going on? Whoa. Oh no, whoa. Oh my goodness. Okay. All right. Okay. Find of A. Let's find of A. And find of B. This is supposed to be the parent. Like, I don't know what is going on here, but I'm not seeing what I'm supposed to be seeing. This is really weird. I don't know why this is happening. They both should be the same. What is going on? Find. Huh? Huh? What? What is happening? Hello? Array of A.P. Array of B.P. What is going on? I definitely implemented it incorrectly. It's just. Yeah, so this is what you're supposed to get. Something like this. But why is this happening? Yeah, they just stay the same. What the heck? They're supposed to be merged. What happened? What is going on? Why? Okay. What the heck? How are they already merged? No, no, it's called. What the hell is going? Excuse my language. What is going on? What is going on? What? A and B are different from each other, so alpha and beta are different from each other. What's happening? Excuse me, I'm so confused. Alpha index. Maybe that's the issue of these different indices. No, that shouldn't. Huh. No. Oh. That's starting to hurt here. Feeling like kind of sick for some reason. All right, what are these indices? What is going on here? Oh, pain in the neck. Okay, yeah, the indices are different. And what the heck? What the heck is going on? This is a problem. Something is wrong here. B should be beta. Oh, that's very subtle. Oh my goodness. Why is this? This is hard. It's hard. No. That's what I get for freaking not thinking all the way through. Oh my goodness. So bad. That's so bad. It's very subtle. That's an easy mistake to make. I didn't I swapped these pointers, being so clever, swapping the pointers, but you can't use A and B after that because you swapped. A and B don't refer to the same things anymore. Oh no. Oh no. Oh, okay. All right, let's submit. See what happens here. Wow. Okay, got it. Oh, I submitted like 10 times. Gee, that was so bad. That was so bad. Yeah, you gotta practice that one. That one's like, it's very easy to make a mistake. The disjoint set data structures. I've done it so many times. I've implemented it on the spot so many times now. You could tell I could do it very quickly, but it just needs. It always requires really careful attention to detail every time. Every time. So this is a relatively efficient approach. This is basically linear time. It's 2 passes, obviously, but it's pretty good. It's pretty solid. You could actually terminate early too in some cases. How are we doing here? This is 1, 2, 3, 4, 5, 6, 7, 8. A couple more. You could do. You could put this in here too. Have it terminate early here as well. I think this also works. I don't know if it's good to add this. It might be. I don't know. I guess we'll find out. Yeah, let's do one more submission. So it's not 100%, which is kind of annoying. I don't know. There might be a way to do it that's a little bit better, that's faster. Oh no, got 100%. There you go. As I'm saying it. So yeah, fastest solution. Got there. Yeah, linear time solution double pass. It's not always the fastest, but it's pretty good. So yeah, hail victory, and let me stop there. I need a break after that. I was on such a roll, getting doing things quickly. Kind of unfortunate. Yeah, I got the last one wrong too because I did it too quickly. Tried to do it too quickly. You kind of want to do it in a way where when you're confident that you have the answer, then you oh man, when you're confident you have an answer, then you submit it. You don't just kind of like rush into it. But I mean, the idea was correct, right? The idea was correct. It's just the idea was correct. It's just the implementation was wrong. I didn't realize it. That was the second submission. The first submission, the idea was wrong, and I just didn't think it all the way through. That you have like that you could have like transitivity. That this equality is actually transitive, and so you can't just take the pairs of things that are equal and the things that are not equal and compare them. Although that would be inefficient. That would be efficient if you could do it that way, but it's not actually what it was needed for this problem. So yeah, hail victory, and I'll stop here. I don't know if I'll pick up another one. I think it'll just be it for today. So yeah, I got like an hour and a half or so today. Not a lot of time, but just step at a time, day at a time, step at a time. Just kind of go meander my way through life here, through things. I have so many things I got to think about and contend with. There's like a million things to think about, to deal with. But yeah, all right, take care.